Okay, so I'm going to give you some notes on a class of reactions called redox reactions. Now, redox comes from two reaction types, or two processes that happen to make this kind of reaction. The first is called reduction, and the other is called oxidation. Put them together and you get redox. So this type of reaction, basically, these two processes come together and we're looking at an exchange of electrons. And that is redox. Electrons. So the first reaction, or the first process that happens here, maybe not first, but the first one I'm going to talk about, is oxidation. Oxidation is when a substance loses electrons. So when a substance loses electrons, we say that it is oxidized. Oxidized. I'm having spelling problems today. So this oxidation, when we lose an electron, that is one half of what happens in a redox reaction. The other half is reduction, and reduction occurs when a substance gains electrons, specifically usually an element. So in some more, typical chemistry textbooks or advanced chemistry, they talk a lot about oxidation numbers. And you may be wondering why, when we're gaining electrons, we're reducing. Well, it kind of has to do with this oxidation number idea. You can think of, for the purposes of this class, and this works in most cases because there are only some exceptions to this, oxidation numbers are the charge on the atom or ion. So you can just say the charge of the substance in question. So think about it this way. When you gain electrons, in general, a positive charge goes to 0. It has reduced from +3 or +2 or whatever to 0 by gaining those electrons. So most cations, when they gain an electron to become a neutral atom, they reduce their charge. So that's where we get this idea of reduction. Oxidation kind of comes from the fact that a long time ago we thought it was only oxygen. It's not. Lots of things oxidize or get oxidized. So if you're wondering how you're going to remember the difference between oxidation and reduction, that one loses and one gains electrons, there are a couple of mnemonics that are pretty commonly used. The first one is Leo the lion says grr. So Leo, like this constellation, Leo, and grr, like the sound the lion makes. So Leo stands for losing electrons is oxidation, so LEO, and grr is gaining electrons is reduction. The other one that some people prefer is oil rig. So oxidation is loss and reduction is gain. Spells out oil rig. So those two ways are, you can pick your favorite one or make up your own if you want, to remember that oxidation happens when we lose electrons and reduction happens when something gains electrons. So let's look at some examples of this reaction using some examples you've already had. So in the making copper lab, you did the following reaction. You took solid aluminum, reacted it with copper 2 chloride to make aluminum chloride and solid copper. So if we look at the things that potentially changed their charge, you'll notice that aluminum and copper in a single replacement reaction, the two things that switch places, are the ones we're going to examine. So let's look at aluminum. We had 2 solid aluminum that became 2 aluminum 3+, because, as you remember, in an ionic compound, the aluminum would have a 3+ charge. So if we look at this aluminum over here, these 2 aluminum had a charge of 0. Now there are 2 with a charge of 3+. That means that each one of these aluminums had to lose 3 electrons. Now in chemistry, we generally only add things, we don't subtract, so you wouldn't write it -6 electrons because they were each losing 3. You would say +6 electrons over here. So aluminum lost electrons. Losing electrons, if you remember, is oxidation. This is the oxidation half reaction. Okay, we call these reactions of just the oxidation or just the reduction half reactions. Then we look at the copper. We had 3 copper, and that was a copper 2+. Remember, it's in an ionic compound, so we can figure out its charge. And it became copper solid, which no longer has a charge. It's a charge of 0. So in order to take these 3 coppers, which each had a 2+, and make 3 coppers that were neutral, they each had to gain 2 electrons. That makes a total of 6 electrons. Notice that when we put it back together, there were 6 electrons on this side and 6 on this side, and we end up with our whole redox reaction, our overall reaction for the redox of 2 aluminum plus 3 copper, 2 plus, will give us 2 aluminum, 3 plus ion, plus 3 copper. So notice that the copper gained electrons, that makes it reduction. So this is the reduction half reaction. Let's look at another example that you've done before. In the metal activity series, and if you're looking for more on this, there's a good reading attached to that lab. So if you're looking for, from forensic, the metal activity series lab has a little blurb on oxidation reduction as well. You look at this one, what I would like you to do is try pausing the video, go in on a piece of paper, see if you can figure out which one is the oxidation and which one is the reduction. I will give the answer so you can unpause it and then see if you are right. Okay, so aluminum and iron are the two we're curious about here. So you don't have to draw these all out like I do. I always put the arrow, I line them up down the middle, but you don't have to do that. You can just draw your oxidation and reduction reactions however you like. Alright, so aluminum started out as a solid with a charge of 0. It became a 3+. That meant it had to lose some electrons, 3 of them to be exact, and that makes this oxidation. Iron was a 3+. Draw that over a little bit. So iron was a 3+, aqueous ion. It became a solid iron atom, solid iron atoms, and to do so it had to gain 3 electrons. That makes this reduction. Alright, so in the fuel cell reaction, you have the following reaction. You have hydrogen plus oxygen giving water. Now, in the paper model that you have, and in the simulation that you can look at, which is the next step in this folder, you can sort of figure out, you should be able to figure out what the half reactions are. So I will leave that challenge to you.